Yellow, yellow. Okay. And what? So mm, mm, okay. So, so, two, that last one. Mhm. Okay. Holding. So just like this. Okay. Um, so Sierra, I was gonna just try to text you back, but you hear me? Can I hear you? I guess is a better question. I think your mic is off.
Yeah.
Okay. Well, actually, I guess we'll have to try to talk. Like, we'll wait till after class, just because. So, yeah, we'll just make it so everybody doesn't hear you, or if you want that privacy. So, but yeah, we'll talk about a couple things after this. Okay. 10:41. That's fine. Mm. What else? What else do I need to set up for class? I guess. Oh yeah, yeah. Controls going. Okay. Mm. Oh, I'm so tired. Mm. 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 Yeah. Really, and I brought my lunch today. So I'll just have you stay after. Also, but in general, like, it's like that's my only lunchtime. So you got to be able to make. I mean, but I mean, it's a couple things. So, like, you're taking it a week after. That's a huge advantage. You know what I'm saying? Like, so you can't have that advantage over other students. So it's like you got to make sure you can be here the days of. I don't know what your other professor was doing. They shouldn't have had you taking a test that long.
Yeah, it was for physics, something like I had to do it right then and there and just it's online thing.
Yeah, yeah. But it's just I mean, I'm not saying I know you can do anything about it, but just know that like every faculty is only allowed to give tests during their period of time. So like he shouldn't have had you doing something that overlapped with
No, no,
the class.
it's,
Yeah.
usually I have it's an online course.
Yeah.
And he was just like, no, it has to be done. I have from 9 to 10 30. Was like, oh, that's when I'm free.
Yeah.
And I just stay like
Yeah. Gotcha.
I
Yeah.
usually chill in the library and just do it on there.
Yeah. So, but yeah. Okay. But yeah. 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 Hopefully not. But in the future, we'll just have to make it work during office hours. Yeah. What happened the other day though? Because I know you're gonna come in at
Okay,
9.
because I went in, I thought 9:30 was like maybe he's busy. So I was just like, I waited for a bit and I was like,
Well,
okay.
did you go to CHP 220?
Uh-huh.
I was sitting there since 9
I
o'clock.
was in siege. I had a hard time with it. I was going to ask, but it's that one right there. It's called the nursing building too.
Yeah, yeah, the nursing building.
Uh-huh.
I'm telling you, dude, like I specifically got in at 9 o'clock. I was sitting there in the office. Like,
Yeah,
did
no,
you?
I was just sitting because I was like, I don't know if I want to walk into somebody's room, so I was just sitting in the.
Okay, next time knock on the door, man, because we could have already had this knocked out, and like I could have gone somewhere for lunch today, and I'm not trying to be like, but it's like you were there. All you got to do is knock on the door. Yeah,
Understand.
yeah. Oh man, that sucks. We could have that done. All right. Sweet. All right, let's go. All right. All three of my classes, we kind of left off in different places on this. So tell me the last two problems that I had shown to do. Tuesday. Quadratic. Say the quadrant. We read it out. Oh, okay. 4x squared plus 3 minus -2. Okay. That was the last one. So does anybody else have notes? Because, and I'm not saying like, that may have been the last week got me down, but I know with this class I got farther than just that quadratic equation. What do you think? We had gotten to, I think with this class, I think we got to ones where you didn't have 0 on the other side.
Oh yeah, you're right.
I think yeah, we did one like that. It would equal to 10, and then you throw it with some kind of
Yeah, it was like four, it was
Yeah.
4x2
Yeah.
plus 3.
Yeah. Okay. All right. So we got there. All right. That's good. So then. Yeah. Did we do any that weren't squares, that had common factors? Did we talk about common factors?
That is, but we never did one.
Okay. That was good, yeah, all the next. All right, so then let's look at something with common factor. Yeah, so pretty much everything we got through on Tuesday was working through the CAT method. So there are problems though that method doesn't work well for. So we might see something like politics. Um. Something maybe that's. Where it looks like something. An experience, fortunate experience. And what do you notice? What kind of, I mean, well, what do you see different or maybe the same about this compared to the problems I was saying? Yeah, so the first thing is a higher power, not divided by eight. Go ahead and say it's cubic, you need to divide by eight. Surprisingly not eight, but. Two. Yeah, but don't try to get to the answer yet, so you're good, but
Okay.
yeah, let me make sure everybody kind of sees, like, the concepts are more important than the numbers, we'll get to the numbers, and you got it. All right, good, so we see a cube, and I'm not saying every one of the problems that you use common factors for has a cube, but often. That parenthesis, the two parenthesis method sometimes works on things above a square, but most of the time it doesn't. So that's actually one of its restrictions. It essentially doesn't work on a lot of problems that have powers above a square. Also notice that on three terms, that parenthesis method also doesn't work on things that have less than three terms. So this is just a good example of a problem where if you wanted to use the cat method, it just doesn't even play. Doesn't. But on that list, on that list of factoring methods, the first one I gave you guys was factoring out a common factor. And yeah, like several of y'all mentioned, I had sort of teased that that's actually the first thing you should look for. And so we want to go back to that idea. The first thing you should look for, even in the problems we did on Tuesday, you should look for a common factor. All the problems on Tuesday didn't have a common factor, but this one does. So the first thing you want to do is look for a common factor. And so then back to what do you see that these two terms have? So first of all, it seems like they have an x squared in common. So they both at least have two x's multiplied. What else do they have in common? Yeah, divide out of two. So when I factor out a common factor, what I'm going to do, so factoring out a common factor, it's a different way of undistributing, but it's still the same thing. So all factoring is undistribution. Your distribution. So I'm going to write 2x squared, my common factor on the left. And then in the parentheses, I just want to figure out what does 2x squared have to be multiplied by to give me what I see up here. So for instance, 2x squared times 1 gives you 8x cubed.
Squared.
Why
not squared?
Yeah, not squared, but x, you got it. And then 2x squared times 1 gives you negative 14x. It'll be a negative 7. But that's all you're doing here is you're literally, visually, you're thinking through the distribution you would have to do. So that when you multiply it, you get 8x, you get back up to 8x cubed minus 14x. But notice once you do that, I have two factors. They equal to 0. So I can do exactly what I did for all the other problems. So the only difference in this problem is how you factor it. So there is a common factor, so you want to do that to begin with. But beyond that, you're going to set your factors equal to 0, solve them, so it's a safe way. So I want to give you guys a couple minutes to work through that, especially to see what you do with one of the factors.
I would think would think using the okay. Let's hear this thing off of my head when where it equals 0, so then I will look just erase the parentheses. You know what I mean? Which means, we need to see what man. No, I didn't say. That's the negative.
So by factoring
I was just looking at this, and like, a lot of years
that. So likely the reason I want to do this is you'll see by the end of today that all these problems,
it's like, whenever like,
you start out, get an equal center factor. Percent factor. So I wanted to trust. Like, build that math on those functions.
Okay.
Because that's the one. So if we go back to see. Like this one.
I was wondering,
So you back. So I think I'll say it's sometimes by saying it's eating, so they could have copies to me.
yeah, you can understand it, it's all I'm saying, bro, I mean, that's not this fact.
So every law. So the same where
Oh, so we gotta see what equals.
still, you got to plus that, you do the same thing.
You get it?
What's that? You do what's that?
Yeah, you know what I mean.
Did it right there? That's what's my name. It's pretty loose.
What's that?
On the side.
Like the, and you get there. So they would miss it, that.
Today's which you get. Do you work there?
It's gonna export that you want.
Yeah.
Teaching.
Yeah.
Take some of it.
So basically, this is surprisingly, we're still essentially like.
Because it's negative, still. So then it's hold on.
I was
So
already.
do this 3.5.
Today, that's like, gonna be like a little conflict.
Look equal.
Then what's the opposite? Square.
It's so nice.
And you do.
Better, it's not.
No, I mean, when you're plugging in, so what you're doing is you're gonna use something you did. In last year. So yeah, when you, if this was an X.
Did you put it in that thing?
But what is just the opposite?
No, I
Like,
don't know.
Function is the opposite.
Well, nice.
What's the opposite? Just Right.
No.
You know, it's been
Now
started.
it's.
So is there something we're trying to find?
No.
Yes, we.
And there is.
Like you sign something or.
And you said this.
So square root.
It's like, they'll just,
You know, person, we're gonna just scribble.
well, it's just.
Square.
Like,
No.
it looks good.
I didn't. Basically, it's square, what was it?
Very nice.
Exactly, it looks illustrative.
Yeah.
Okay, but.
So it's actually still it's getting. It's just how the. So why does, when over here, why does divided by two different?
Very blessings. What if you would want your.
This is actually how this is. Do you know how you use division?
Damn, what is it?
So.
Logan, my radio.
So right now.
Easy time.
No,
Easy.
no, it's okay. So. I mean, it's the same.
You guys like 27.
You love?
Like, it will be the same word that is in.
Square root is less than. So naturally.
Let's do it.
You said.
How great you talking on?
Yes. Then you would, so if this was.
It's still automatic now.
Yeah, well, those pages do it. So that's a lot, there were a lot more equation on.
That's great.
Operation.
Oh, yeah, so you share it through the, you see.
I haven't finished it, I'm still through the
I'm
one.
not gonna lie to you. Ever since some years of now, it's finally watching it, and I hate the way it ends. I don't like it.
Excuse me.
We could two groups or four different codes. Very good.
All right, so for the 2x² = 0, what did y'all get for the answer? And how did you get there? Yeah. So you divide it by 2. That's x² = 0, and then to get rid of square, the opposite operation for square is square root. So you're gonna take the square roots. But the square root of 0 is still just 0. So this is one of our solutions. All right, and then the 4x - 7 = 0. Somebody take me through how you solve it.
Oh, so you, you were here when we started.
Add 7.
Add 7.
Yeah.
Right. Divide by 4.
And divide by 4.
You can simplify that.
Good, yeah, good. We can't simplify that any farther, so that's our answer. Any questions or any issues?
Why are you getting this?
Why what?
Why do you do this?
Because this is a separate factor, there's multiplication there. And so like on previous problems, we'd have like an x - 3 times x = 5 or whatever. But there was multiplication. So as long as multiplication is separated, they're a separate factor. What other questions?
Now I see. It's my what you do? Is that what it's done with? Nine.
All right, so thanks for the time we have left. I would like to do a practice problem on one, but I think it's pretty self-explanatory from there. So let's look at another one where we might look at different compacts. This does have three terms, but it still starts with. So yeah, that's the kind of stuff that's your tell there. Definitely, we like to have common factor. So what do y'all see here? What's kind of the common factors here? Yes, about a three and what else? Yeah, they all have at least an x in common. So 3x is one common factor. So then I'll give you guys just a minute. We'll kind of do this piece by piece, but what does that leave us? So take a minute, figure out the rest of that factor.
Do it. Might just be that again. Yeah.
All right, what are y'all getting? So 3x times. Is
Ice word.
X 20. Yes, perfect. Alright, so 2x times, or 3x times 2x squared minus 3x plus 1. And we got 2 back, and we can set those equal to 0. When you set this equal to 0, though, what's kind of think this forward? What are you running to? What would you have to do to factor that? You'd have to factor that into 2 parentheses. So I kind of bring this problem to show you that sometimes you're gonna have to do 2 sides of factoring, but you'll see it in the problem. Show you. So exactly like y'all said, we need to factor actually that into 2 parentheses. So again, I'll give you guys a couple minutes to do that.
You're thinking that 30. Oh, yeah, me too. You put the when you have 25. Nah, I guess I'll do the 2x2, that's the square. You see what I mean? Because like here we have to keep it like this, so that's a cubic, so that the other thing is good. No, I'm not sure, probably don't know, but you don't know worry about that once you put that. When you do 3 by you, but 3 by 6 is 2, that's 2 is, and you get 3 by 9 is 3, or gonna be about 2 minutes. Now we're gonna go, I'm really, I have, see, yeah, he's really smart. Yes. So this year, and then you know, this is really great, so 2 minutes. Something to be what's up to them to. It's like my. It's down.
So you get the number. In this town. Yeah. That's not. Well, what if the-
No, you what you have to do it. Then you get how you got that plan. You get the rest of it.
That's not the good way you do it.
No, I'm new. So. That's what you want to.
Okay, I got
That's all. Do it.
What are y'all getting from that?
Yeah, this is not.
Before, I think we'll have to reverse. Plus five.
Money's scores. Yeah, it's free.
Yes,
The two.
well, but 5 times 2 gives you 10. Yeah, so because that way you'd end up with negative 8x plus 5x, which is negative 3x. But then 2x squared. Yeah, yeah. But good question. So anybody have trouble getting this? Okay. So now we have 3 factors, but it's the same play going forward. So this is something I was mentioning to her back there that you're gonna see as we go through these problems. Every one of these problems, as long as you can factor, the overall play is exactly the same. Factor, set them equal to 0, go solve each of those pieces. So you can trust that as like that playthrough gets you through all these problems. The fun part is just you get different equations that require different ways to factor, and you're the one that kind of figured that out. Okay, so we got three equations. 3x equals 0. 2x plus 5 equals 0. And x minus 4 equals 0. This is easy enough. Somebody just take me through the 3x equals 0. How do you solve that? But 5 by 3. To get x equals 0 there. Good.
When does it become undefined?
It's when it's on the bottom. Yeah, you divide by 0. Good question. What about the 2x plus 5 equals 0? Would you solve that? Minus 5. And perfect. You'll we end up with -5/2. And then add 4. Good. So x equals 4 is our third solution. And it's a third power problems or third power polynomial is what we'll call it, but it's third power equation. So we can expect up to 3 answers. This actually is. Okay. So then what we want to look at. Alright, so they'll also have these all things like the following. What's different about these? And what's the same compared to the previous ones? Good, so there's no zero on the end, and that's a huge difference. So let's talk about that difference. So again, on this problem, these two problems and all our problems on Tuesday, we always had a zero on the end, and there was a good reason for that, because we would always get to this point in the problem where we factored everything. And the point of the factoring was now I have a bunch of things that multiply to give me zero, so what do I know has to be true about about those things? They have to equal zero, or at least one or more of them have to equal zero. And so that's what allows me to set them equal to zero and to do the actual solving problem. So again, it's a factor, but I need the zero, so that then I can set the factor equal to zero. So the problem here is I don't have the zeros, but we actually have probably a pretty easy solution to it. So, what do you guys think? Just looking at it, what do you think would be an easy solution? Just moving, yeah, so I could move the 12 over. Because then I would have a zero. And like on 14, I could move the 18x to the fourth one. So I was telling everybody, this is not math strategy. This is just common sense, kind of practical, like strategy. If you've got one new thing in a scenario that messes it up, try to get rid of it. And you can't always, but if you can, then now the scenario is the old scenario and you know how to. So the good question. Yeah, so let's look at this. These are gonna give me a zero. Are these like terms? Yeah, yeah, so we just move it. We're just moving it up. Same thing. So we get 12x to the fifth minus 18x to the fourth equals zero. But again, this is bingo. That's what I needed zero. So that we then can make the same overall point factor. Then your factor is equal to zero. So again, I'm really emphasizing, I promise you guys don't actually have to memorize how to do these problems. You just have to memorize that playthrough. Because it's the same on all these problems. Remember, understand. Well, number 4 does end up being. Oh, so you're saying to begin with, dividing out a common denominator? You could.
Yeah, so like, you wondering like why is the tracking to solving by like these things?
You could. I'm trying to keep them some consistency, but you understand. If this had, well, hold on. I think this is the thing you always struggle with. It's like you're trying to be like, what is the method that you want? And the thing is, like, we're past that with mathematics. So you're right. My method works, and so does yours. You might see some problems if you have any more than one terms, like if you had two terms on the right here, or two terms on the left, then you could. Yeah, I don't have behind. But for this one, because it's just a term back. But either way, we just gotta factor, do our business from there. So I will give you guys some time, a little more time so you can work on both of these, but we'll work both of these problems out.
Yeah, 34. Just I'm gonna go. You ready? Oh, on. Or it's gonna go. Um, use the- yeah. Yes, because like, okay, so it's an audience well, right? It's just some feels slow, like when people have them, they can make it. Yeah, you can, this is,
And I use, oh, wait,
I, no, it just, it's like, you see, I was like, what time, so it isn't 2 minutes, so you have 2 inches. And -8 times 3 is when -24. And if you add both of them, it would -5, and then -5 is right there. And you get 8, and you get the other one. Good. You're here. Close. So skip from the other eye. Going to. I was thinking this. Then not like. Either way, he wasn't thinking that, but we don't pass his pass. You heard, so we all want to stay. It's good, I rather this to be. Two pounds. I would like having one of those ground.
You would agree.
Makes me.
Also, future shit.
You make me so. That's fun. I hear his mirror. I know Anthony goes to, he'd be sticking to his glass. Yeah, like probably. I give him a hug every somebody. Sometimes. That's what's up.
Oh, wow.
I'm telling you, you put a thing on YouTube. I'll put a day over here. My thought. No, you can't tweet them. What is it? Sick. It's the greatest comment. You right, you
Alright, let's see where you guys go with this. Easy. So let's see. So somebody. Let's do it this way. So this first one. Let me have, so the three guys back on the left there. Any of y'all have this one?
Yeah, I got,
You guys have a lot of good conversations about this stuff.
-6 and -2.
-6 and -2, and just kind of take me through the factor.
So first I did the, it was like you could use the two. So I had x -6 and then x -2.
X minus 6 and X minus 2, perfect. That is the correct factoring on that, good.
You want me to do two?
Oh, yeah, so then you're gonna set each of those equal to 0,
Wait, I was.
and basically same thing, so they should end up positive, but so you should end up getting x equals 6 and x equals 2. Yeah, you got it, nice. The consternation there. Then what about my ladies in the back? You guys have 4, yeah, did you have it go on 4? Okay. Okay. I'm gonna take out a larger number, but we should end up getting the same answer. So you can definitely take out a 2. But it ends up on this one, at least the largest you can take out is a 6. And the thing is, so the weird thing about this is that actually though, like when you guys solved whatever you got for this other factor, you still would have got the same thing as we did. So, but so first, if you take out 6x to the fourth, what's left in there?
Maybe
So 6 times 2 is 12, x to the fourth times x is x to the fifth, so we're gonna have a 2x there. And then we would need -3. 6 times -3 is -8. And then what y'all would have ended up with is what? It would have been 6x minus 9 instead. But then either way, we're gonna set those factors equal to 0. So for the 6x fourth to the equals 0, how do you solve that? Start by dividing by 6. And then, so we've had second power and we got rid of it with the square root. So if we have fourth power, which root should we use to get rid of it? Or do you think we use? So there is something, so really quick as a good little summary here. I think we did talk about it earlier in the semester, but so if I have something like 4 squared, what is 4 squared? It's 4 times 4 times is so. 60. And then if I do square root of 16, and we now know we'll get 2 answers, but let's just take the positive answer. If I do the square root of 16, what do I get? You do get 4. So what is square root? It's maybe what's not really throwing you guys off, but causing you to hesitate. What does square root mean? So like when I do square root of 16, there's again, you'll see it all throughout the class. Promise you guys, if you go by what stuff means, you do less thinking. It actually makes the math easier. So when I do square root of 16, what it means is I'm looking for what times itself gives me 16. So that's what square root means. I'm looking for kind of like I have a number and I'm looking for the pre-action. What times itself gets me to that number? So in this case, it would be 4. So notice that squaring something takes the number and multiplies it by itself, and then square root just takes you backwards. It just undoes that. What times itself gets you to 60? You could do this with other powers. So 2 cubed, 2 times 2 times 2, what does that give you? Yes. So then there should be a root that allows me to look at 8 and ask myself what times itself 3 times gives me 8, and there is. So they use the same symbol, they'll just put a 3 up in the corner. So the cube root of 8 takes you back to 2, because for the cube root, I'm looking for what times itself 3 times gives me 8. And so every power has a corresponding root. So fourth power would have a fourth root, fifth power would have a fifth root. They stopped really naming the roots because mathematicians get lazy or very easily. So going back to what we have here, 5x to the fourth equals 0, I need to do a fourth roots to go backwards to get rid of it. But what times itself 4 times gives you 0? Still 0. That is one of our solutions. And then what about the 2x minus 3 equals 0? Plus 3, perfect. 2x equals 3, and then try by 2. Any questions? 11:30. That's it. I didn't sleep at all last night, so if I fall on the floor, just let me sleep. Yeah, it's just don't call the ambulance, just let me sleep. So. Um, well, so I have a roommate that moved in my place, and she had a friend, she had a guy that came over, and he's cool, so we all just ended up hanging out. Yeah. So, and grading, actually, I was grading y'all's homeworks till about midnight, when they came over, and I graded it, or like, I just didn't sleep, I like started at like 5 in the morning, just graded the rest of y'all's, not homeworks, y'all's tests. That was the other thing. Very. Able.
I think it's, yeah. She did, if I. Yes. Yeah. All right, let's look at something like this.
So I want to solve something like this. And we want to check the same things. So does it have a common factor? So I'm hearing two maybe. And two works beautifully here, here, and here. The problem is here. I don't have the coefficient there, so I can't. Say it again. If there's, so algebraically, you just end up, when you leave one out like that, but that's not a bad. It just kind of doesn't, it doesn't work. But we're gonna do something similar, just not one, but pairs. But the point you brought up still is really good, that again, X looks like it's good, except for when you get to the last term. So this one doesn't have a common factor. It also is more than a squared, and it's more than 3 terms. So we actually can't use the 2 parentheses. We can't use the cat method. So no common factor, can't use cat method. What do we do? So there is another method that doesn't even work all the time, but they're going to give you some specific problems where it works. There's another method called grouping, that allows us to kind of work something like this. Part of what grouping is, so grouping is really 2 rounds of common factors. So we said there wasn't a common factor for everything, but still, when we look at it, we're like, but if I could just pair these up, like pairs of these definitely have common factors. The problem is there's always that one extra piece out of the 4 of these that makes it so you don't have a common factor for everything. So that's actually what we're gonna do. So grouping, they call it grouping because we're gonna start by pairing up pieces that have common factors. And then we're gonna do 2 rounds of common factors, and you'll see it'll get us to factor this. You don't always pair up the first 2 and the last 2, but it's works well on the problems they're gonna give you. So I'm gonna pair the first 2 and the last 2, because the first 2 I see have common factors, and the last 2 I see have common factors. And what's the common factor on the first? X squared. Yeah. And then what would that leave us? So x squared times x gives me x cubed, and then x squared times -2 gives me that -2x squared. What's the common factor on the last two? 2, but I'll go up to 4. And since the lead one here is a negative, this just helps work the rest of the problem, kind of get the rest of the problem to play out the way we want it to. I'm gonna factor out a -4. So that's just sort of, that's not a math law, that's just sort of a good rule of thumb. If the lead part is negative, you should always factor out a negative. So what does that leave us? So -4 times what gives me -4x? X, and then -4 times what gives me? That would be -2. Gives me 8, so that's one round of common factors. What do you notice now about this? Looks horrible, but what do you notice about it? You got the x minus 2 common. So the idea on this second round of common factors is this looks like a beast and this looks like a beast, but nonetheless, this is one part, one term, that's another part, and they have an x minus 2 in common. So I'm gonna factor out the x minus 2 and pull that to the left. And then I basically just get to drop in parentheses what's left over. So visually, what do you see? Without the x minus 2 is what's left over.
X squared minus 4.
X squared minus 4. And we've factored by grouping. Yeah, and so now if you want to, you can set these equal to 0. I actually want to see, with the last class I was kind of testing, so when you guys look at this, so one of the next thing technically to do is to set these equal to 0, but when you see the x squared minus 4, if I set that equal to 0, does that look like something you can do and you can solve? I think the last class too, I was kind of, I've had some classes where they just, it doesn't look familiar to them, so they don't know what to do with it. But I think you guys will. So yeah, from here we do the same thing. Set them equal to 0.
What are you getting at?
Yeah, we can possibly get imaginary numbers. Not on the
Square root of it.
square root of, yeah, yes.
Plus or minus.
B plus, yeah.
Yeah.
So that's what, so all those little things, imaginary numbers, plus or minus, I actually want to see how much of that y'all remember. So let me have you finish this out. Set these equal to 0 and get your solution. So let's see what we get. Yeah, in this case, it's probably like the negatives would come. That's like that.
So like, sound good, and then and then to bring that thing around, and then you would write it to. Yeah.
What to?
To get rid of that, you don't have my form. You put like,
So this is
pretty much.
let's wait.
I got you. Pretty much, so.
How it goes?
Right? Yeah, and you like this. Oh, no, it's two. Yeah, I just do.
Look, you got to
Everything's
do.
If you get two on the left, if you get two on the left, you get two on the left. You get two. You get ten. Yeah. Oh man, these two.
No, I'm not saying what the answer is. On
Yeah, I'm just. Yeah, but well, I'm yeah. What grading claims does it mean? We're grading, we are. So. Is it? Whatever. Oh, yeah. 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 Oh, where? It's just the way I'm. That's
Let's see what y'all are settling on. So x minus two equals zero.
Us.
Yeah, plus two. That's x equals two. How did y'all go about solving x squared minus four equals zero?
I added forward to
Yeah.
both sides.
So add four is a good start here. So basically, we're gonna be able to get x by itself. We don't need to do anything fancy with squares. So we add four, so we have x squared equals four. And then what did you do from there?
Square rooted.
Yeah, square root is the opposite of squared. So I'll square root it. And what is the square root? Two. Surprisingly, there's a second answer though. Negative two also. So if you think about it, negative two times negative two is also positive four. So in a lot of problems that you see up until this point in mathematics, they'll give you a square root in a problem, like you'll see it physically as part of the problem. And when they do that, they're always they basically are assuming like the positive answer. However, in reality, not just four, but anytime I take a square root, there's always two answers because a negative times a negative is a positive. So the negative version will still give me that positive number that I'm looking at. So from now on, you're gonna be doing the square root in the problems. So you've got to account for both possibilities. So this is x either equals two or it equals negative two. And we already have two over there, so in some sense, we actually just got, see, it's really just two different solutions. Another way you'll see them write this, so another way you can write this, you don't have to, is just plus or minus two. Which you probably remember this symbol from like the quadratic formula. That's actually where it comes from. So in the quadratic formula, you have to take a square root. And so that's why there's the plus or minus. So you can write it. All right. I want to just talk, let's see, where are we on top? Yeah. I want to maybe talk through one more problem. We may not be able to solve it all the way, but you guys will have the idea of where to go. Also because Steve, this next one. All right, so we did a bunch of problems Tuesday that could be factored with cat method, and then we did some today that was common factors. And now just grouping. What happens? So the question is, what happens if you can't factor? So what if you try all three methods and nothing works? You have some equation, and I've asked you to solve it, and can't factor it. And the unfortunate answer is it doesn't mean there's no solution. But what I'd like it to be is that there's no solution. But more often than not, so polynomials that you can't factor, or equations that you can't factor, often have solutions. You just can't find them back. So let me give you, well, Not yet, I'm saying. But so for instance, maybe something like x cubed minus 4x plus 7 equals 0. This has solutions, but it can't be factored. So just because it can't be factored doesn't mean there isn't solutions. Now the question is, how do we find those solutions? So something like this, we're not going to be able to figure out the solutions for this singular polynomials. But we'll build up to this. And after 700 years of studying equations like this, polynomials, there are still plenty of these actually that we have no way to actually figure out the solutions. We have no method. So one thing I want you to kind of know is that there are a bunch of things like this that have solutions, but we don't have a method. That's one of the fun things of theoretical mathematics, is actually trying to find methods for things that you don't know how to solve. Practically, when you get into engineering or something, you need to solve this. If you don't have a method to solving, so it's called numerical analysis or linear algebra to basically get approximations. So you can't get the exact solution, but you can get something close. And so there are things like this that you're not going to see on your homework because we don't have a method. But there are things like the following. Let's do. Looks like it's something. So x squared minus 5x plus 2. And if we try to factor this, we would find that it can't be factored. We just honestly, it's actually a really good exercise for you to try to do it to realize you can't. We just don't have the time, but there's no common factor. And then if you tried to do this into 2 parentheses, it wouldn't work. Because honestly, in 2 parentheses, the best we could do is an x here and an x here, and then a 2 here and a 1 here. But that doesn't get us to negative 5x. So this is a true, they call this a prime polynomial, can't be found. But since it's a squared, so the only other tool that we have that we're going to have in this class for things that can't be factored, it only works for squareds, but it is good old quadratic equation again. So remember, basically, quadratic equation, the way it goes is they basically say if you've got this setup, so if you've got ax squared plus bx plus c, you've got something like this, then you can get the solution for x by doing negative b plus or minus square roots, b squared minus 4 ac, all divided by 2a. And this is horrible to memorize. It honestly took me years to memorize. I basically had to recreate this equation in my head every time. So this is the fun thing about being a mathematician. So I never memorize things. I just keep recreating the equations because I can. I'm not saying everybody should be able to do that or can do that, but if you can, it's nice because you never have to memorize. But anyway, so it took me years to kind of memorize this. But this will solve any quadratic equation, actually. And so essentially, you're just going to identify your A, your B, and your C. So like in this case, your A is 1, your B is negative 5, your C is 2, and you plug them in, and then you simplify this as much as possible. And sometimes it works out nicely, and you get whole numbers and fractions. Sometimes it doesn't, and you end up with a square root. You have to be able to simplify that square root, and you end up with fractions, so you have to simplify. So there's a lot of little bits of simplifying work in here. But as long as you can do that stuff, then the nice thing about this is it is just plug and shove. You put the numbers in and work it out, it gets you 2 minutes. We don't have time to kind of follow through or go through on that. Give me a second. But so I just want to show you that that's your tool for squareds that you can't factor. Otherwise, let me pass back y'all's test. All right, it's This will also help me further attempts to memorize people's names. Callan. Ethan. Serena. Loudon.
Like domain uses.
No. And you're gonna let you know.
Serenity. Genevieve.
No, you got it, you got it, you understand it, don't you?
Oh, you got it.
Sorry. And I said your name wrong again. I even asked you at the beginning of the semester. Say it again. Sorry. Sorry. I was so more Arabic than I was going. Maria. Let me look up the names. Ariana. Awesome. Settings. James here. She's Anthony. Anthony. Leslie. Sarah. Jay.
This is I wanna have.
It's not very dumb.
Xavier.
Alex.
Shaden. Savannah. Stunning today. Diego.
Not bad.
I guess I'm gonna move stays.
Victor.
Oh, no, that's easy. Look at that. Look at that. I actually got the cheat sheet.
All right, so that's, if you got the test, then that's it, okay? So again, on the homework, there's two, don't do the second homework. So the one that says other equations, I just haven't had a chance to label it for you guys. Please don't start that homework. So, or did you already start it? Reading? Okay. This would be, because I can't decision. Unfortunately, I think what I'll do is I'll probably just don't keep going. I think I can. Yeah. All right.
What if I start with now?
I Saturday?
Oh, good. Got it, I got it.
The regular.
No, you're right. I remember. Yeah.
It's not dead, no.
Okay.
Sorry, you should. You want to even go.
I should,
I got it.
gonna see, there's a really good.
If I can tell you that I'm getting a server on the little space and like some penny there.
But they have a really good concert on Saturday. Yeah.
Like a little venue?
At Rock Box, Vibe Center, and then I'm gonna sing a couple times this weekend.
So you're gonna sing?
Yeah,
Oh, food?
yeah,
Oh, yeah, cause you have a. Yeah.
yeah. So, in fact, and that'll be the other, we might be able to get a practice in with one of my bands
Yeah,
this weekend.
with the weak voice.
Yeah. Maybe. All right, so we're going to yes, it will. Yeah, but first of all. Physics. Unfortunately, I mean, no, surprisingly, I should know that,
There's one I remember.
well, yeah, the capital is that problem. What do you,
Doesn't think university. Those two.
okay, oh, yeah, I mean, like, I know the calculus two teachers back then, like, well, I don't think I'm a calculus teacher, but I had a teacher. But the university physics, I know that was neuroscience engineer. So yeah, I mean, when you get there, like, just, yeah, calculus two, university. Yeah, so I probably should be somewhere doing the research job.
So, I took conference business.
Yeah,
And then helped as university. Sustain or
I mean, there's probably a little more overlap. So not the on ramps, but the big difference, so like university physics and college physics, basically the big difference is, what do you call it? Newton invented calculus to do physics. So when you take university physics, you do physics. So like, and that's why, like, so if you take the Cal one, then the next semester you take physics, because literally physics one is just Cal one applied to reality, like applied to motion. And then once you're done with Cal two, you take physics two, because it's the same thing. So university physics is honestly doing physics the way it's supposed to, just use that, college physics is just, they tell you equations to use. I don't know why you use them in it. So college physics is usually for people who just get the credit, but not really required with it. So basically you really honestly don't want to take college physics. So for the on-ramps, you might have some overlap, but with the on-ramps, I don't know, did you guys do a lot of calculus in the on-ramps class? Yeah, so you did more of the concepts, basically, when you back to it. You probably did equivalent college. So I mean, that like the concepts are really exactly the same, but instead of being given the equations, you're basically looking during this sentence to figure out all the equations. So, yeah.
Do I need to compare it, right?
No, it really isn't, like, you don't need to like rehash. Honestly, if you pass calculus one, then you can do all the math. So you don't need, you just need to do the derivatives. Yeah, that's really.
Just remember to say narrative.
Yeah, no, it's fine. I mean, that's the thing is like, it's really is design, like. Physics is kind of, it's just like. So the thing is like, it's actually better to think. Because you understand it and see it the way it's supposed to be seen, so it actually. So don't grab this, you're good, you can make derivatives. Thank you. Yeah. You're welcome.
How's your consistent?
So far good. We just got through our first test, and I don't think there's gonna be any hiccups. Literally one or two people per class that are struggling, but that's like, so, yeah.
Amazing teacher. That's my favorite math. It's just I feel so horrible because my mom, she works for a school too, and I feel so horrible just thinking about it much time because I thought it was. So I was like maybe Monday, because I don't.
Yeah,
But I don't want. Yeah,
yeah,
I'm
like I
not
said,
gonna-
just
I'll
wanna
be
be-
true to myself.
Yeah.
I didn't. Since I know like my friends are here, they took
Yeah.
it. I felt bad. I didn't look over the thing. I was gonna go.
Yeah, okay, that's cool, yeah. Yeah, that's actually, thank you.
So I felt it's just my what's it called, like when nobody's looking. That's what I like doing. I always forget what it's called, but it's like there's a habit that there was like 7 habits that I remember. There's like
Oh, okay, yeah, like, characters.
Yeah,
like,
I did the right thing when
doing the
nobody's
thing
yeah.
really, so.
Because I had this one teacher, and at the beginning of the school year, when we're in class, he said that some teachers just give out lots of work without explaining it. That's what my high school teacher did. He
Yeah,
just gave me lots. He gave me, and I'm taking high school still because I'm a senior.
Oh.
So I asked if I, because I was taking this one and that one, but he doesn't care if taking college, so he'll give me more work than college. So I just told my advisor, said, may I take this class for my, because I already passed, I had the credit. She said, as long as you pass this class, you'll get to walk stage. And I said, yeah, I'll just go two birds with one stone, honestly. because
Yeah,
He would just give us, and now like the people that are in there, they're thinking of letting him go because it just gives work and maybe like 20-minute lecture. Just the rest just gets online, just throwing those.
crazy. Yeah, it's like, that's pretty horrible.
That's why like with the domain and the range and like the factoring he was telling us that, I
Yeah.
never understood it. Like I get the concept, but when he was
Yeah.
teaching, I was like, oh, it's easy, it's more easy than we expect.
Yeah.
It's like, I'm not gonna lie, he'll just write one problem and be like, okay, rest is on work.
That's,
Yeah.
let me see, give me a second, is Savannah still? I think she did, so I'll have to call her.